Okay, so here we have an electroscope as we have used before, and a PVC pipe with some paper, and I'm able to extract electrons and place them on this, and you can see that there are electrons in there because of the electroscope leaves being separated. How do I get them out? Well, I know if we touch it or if we bring some charge towards it, it will work. Can we do something with light? Well, I have a bright light here. I hit bright light on it. Nothing really happens, right? Nothing really happens. I can even take a laser light, really intense laser light, low wavelength, low frequency, red, or high frequency, green. Nothing really happens. But it turns out if we bring UV light towards it, this is ultraviolet light, which is even higher frequency, we are able to discharge it. So it's as if the light strikes this zinc plate on which we put electrons, and it's able to kick out the electrons. How's that happening? Let's try it again. I want to protect it. UV light is not good for health because it can dislodge electrons. That's not a very good thing to do because human body is made of electrons, a lot of them, so we don't want to do that and create ions. So, oops, that's not what I wanted to do. So again, if you shine UV light on it, it will discharge, right? So this is an effect called photoelectric effect, which was explained by Albert Einstein. He actually got a Nobel Prize for this explanation. What he talked about is provide an explanation where the energy of the light photons, let me unplug this light bulb, energy of light photons. So we talked a lot about particles when it came to electrons and maybe marbles and things like that in the previous semester, but we always talked about electrons as particles and light as waves. But this is a phenomena which Einstein described as a collision between the photons, which are particles of light, and electrons. And if the photon has enough energy, it can do a collision there and kick the electrons, which are bound to this zinc plate, off. Whereas if you didn't have enough energy, then you wouldn't be able to kick the electrons out. So basically, there is a adhesiveness of the electrons to this plate. For the zinc plate, there is a certain energy level that's called the work function W. And if you have energy for the photons which are larger than that W, then you can kick out the electrons. That was his thought. So light has different energies depending on what its color is. That was Einstein's premise. So what he said is that the energy of particles of light, which he called photons, is equal to a constant, which we call Planck's constant, times the frequency of light. Or you can write it in terms of the speed of light and the wavelength, if you like, right? So this is the frequency of light. So this is the photon energy. So the electromagnetic spectrum, which ranges various wavelengths and frequencies, as Cecile talked about, the photons, the particles associated with it, are different energy. So the UV light has higher frequency, it has got high energy photons, so it can actually liberate the electrons by kicking them out of the zinc plate. Whereas this red light, or green light for that matter, does not have enough energy. So basically, energy of UV photons is higher than the energy of the green photons, and it's higher than the energy of the red photons. The work function of zinc, which that plate is made of, is somewhere in between these two. So the UV photons are able to liberate the electrons from the plate, whereas the green and red photons, or the natural light, which is made of the spectrum of frequencies between this, is unable to liberate electrons from this zinc plate. So this is called photoelectric effect, for which Nobel Prize was won by Albert Einstein.